All right, these are the problems that you should have done on your own. Let's go over them very quickly. Here we have 3 squared times 3 to the 7th. The bases are the same, so this is 3 to the 2 plus 7, which is 3 to the 9th. And like I said, we can find the number that is, right? Take a calculator, 3 to the caret 9, right? 3 to the 9th power. It's going to give you a really large number. We don't need to get it right now. Exponent notation is sufficient. Number 2, this is 5 to the 1 times 5 to the 9th, which is 5 to the 1 plus 9, or 5 to the 10th. This is negative 7 squared times negative 7 to the first power, which is negative 7 to the 2 plus 1, or negative 7 cubed. And finally, this is x squared times x to the 6 times x to the 1. So this is x to the 2 plus 6 plus 1, which is x to the 9th power. And there you have it. If you have any questions for these, please leave them in the comments or come find me. Otherwise, let's move on to our next set of examples. This next one is called the power of a power property. So just like we had the previous set of logic of what guides it, we have another one here that can sometimes cause some trouble. So let's just kind of think about this for a second. Let's say I had x cubed to the 4th power. Notice that I'm taking this thing in the parentheses, and I am taking it to the 4th power. In other words, I'm taking x cubed, and then this exponent right here tells me take whatever's in the parentheses and take it to that power 4 times, and multiply it by itself 4 times. So x cubed to the 4th power is really x cubed times x cubed times x cubed. So again, we can write it all out like this, and then we could even write it all out even more, right? Because we know that x cubed is x times x times x, and this one is x times x times x, and this one is x times x times x, and this one is x times x times x. Oops, I've lost track of my x's. There we go. And how many x's are there? There's 12 of those x's, right? We could also use this one with the product of powers property that we just discussed. This is 3 plus 3 plus 3 plus 3, which makes it x to the 12th. However, if you've noticed that 3 and 4, if I'm going to take x cubed by itself 4 times, what I'm really doing up here is adding 3 to itself 4 times. Which means that I can simply say this is x to the 12th because 3 times 4 is 12. And as it turns out, that's an appropriate pattern, and it will work that way every single time. So we have a rule for this called the power of a power property, and it looks like this. A to the n to the mth power equals a to the n times m. So no matter what number this is or what variable it is, this to the when you have a power being taken to another power, we multiply those powers together. Let's do some examples. All right, so here we have 2 to the 5th power being taken to the 3rd power. We could do 2 to the 5th times 2 to the 5th times 2 to the 5th. But that would be a lot of work, right? And I don't want to do that. So I'm going to remember my power of a property rule, which says that if I have a power being taken to another power, I can simply multiply those numbers together. So I know that this is 2 to the 15th power. And again, I can do 2, and there's a little caret button on my calculator to do to the 15th power, or I can press 2 times 2 times 2, 2, 2, 2 a bunch of times, but I don't want to do that. So again, exponent notation, acceptable for now. Part B here, this is negative 6 squared to the 5th power. Well, again, I've got a power being taken to another power. So this is negative 6 to the 2 times 5, which is negative 6 to the 10th. Notice again my use of parentheses. that looks like 1 times 0. Oh, that's just because my this cursor was in the wrong spot. Notice again my use of parentheses here. It is very important that -6 be in parentheses because that negative sign is inside and also needs to be taken to the 10th power. Here we have x squared to the 4th power, which is really x to the 2 times 4. So x to the 8th. And our last one here, notice that everything inside this parentheses is being taken to the 6th power. And then this is being taken to the 2nd power. So this is y plus 2 to the 12th power. And there is a way to simplify that, but we will not do it right now, right? That's something for later lessons. So that concludes this, our second video. I have some problems on your Canvas notes that I would like you to complete, and we will go over them the first thing in the next video. So go ahead and go back and do those now.